Hello, I'm Amelia, this is
Liz.
and this is
Kayla.
and we will be covering Newton's 3 laws of motion.
Newton's first law is the law of inertia. The textbook definition is an object's tendency to resist motion. An object will remain in motion until acted upon an outside force. The resistance to motion is also related to the mass of the object. The matter allows the object to remain in its current state of motion. Therefore, the mass is the measurement of inertia. Our definition is an object will continue in its state of motion or at rest until acted upon an outside force. Here the object is at rest and will stay at rest until acted upon an outside force. It is now in motion and will stay in motion until a force is applied. Resistance to motion is also related to the mass of an object. This couch will stay in its current state because of the mass that it has. It will also have more inertia compared to this chair that has less mass and will have less inertia.
I will now be covering Newton's second law of motion, which is the law of acceleration. The textbook definition is an object's acceleration is proportional to resultant force in same direction and inversely proportional to the mass. Our definition is the more mass an object has, the more force will be required to move it. Also, the more force that is applied will result in a greater acceleration. One important thing to note for Newton's second law of motion is the law of momentum. Momentum is the quantity of motion of an object and is found by multiplying mass and velocity. The equation the sum of forces equals mass times acceleration is derived from the law of momentum, where the sum of forces is equal to the mass times the change in velocity divided by the change in time. An external force is needed to increase or decrease the momentum. Here I have two books. One book with a lesser mass and one book with a greater mass. The amount of force required to move the book with the lesser mass is, well, less. The amount of force required to move the book with the greater mass is greater. This can also be seen when kicking a ball. If I apply less force, so if I kick the ball softly, the ball will have a lower acceleration. Whereas if I apply more force to the ball, so if I kick the ball harder, the acceleration will be greater.
I'll be talking about Newton's third law, law of action-reaction. The textbook definition is for every force exerted by an object, there is an equal opposite force on the object. Our definition is when a force is applied by an object, the object will apply the same amount of force back to the first object. In this video, I would like to demonstrate how if I apply an amount of force to this wall should be applying the same amount of force back to me. And this will allow me and the chair to move forward. So I'll be demonstrating it now. The second example I like to demonstrate to understand this a little bit more is walking. So when we walk, we apply an amount of force towards the ground. And when we do that, the force of the ground should apply the same amount of force back to me. This will allow me to push off from the ground and be able to move to my next step.
Okay, so we will be summarizing Newton's 3 laws of motion.
The first law was the law of inertia. An object in motion will stay in motion until there is a force applied. And then an object with a greater mass will also have a greater amount of inertia.
Newton's second law of motion is the law of acceleration. This explains why when an object has a greater mass, a greater force is required to move that object. This also explains why when a greater force is applied to an object, the object will have a greater acceleration.
Newton's third law is law of action-reaction. This is where the amount of force being applied in two objects, and it should be equal and opposites.
But wait,
Newton once said,
no great discovery was ever made without a bold guess. Thank you for watching.